you don't like modeling questions, then this one's for you, mate. Here we're going to be modeling with parametric equations. We're going to do 2 and 1. Students do not like modeling and they do not like parametric equations. This fuse them in it. It says a battery-powered spinner is rotating anyway around a fixed support at O. Its position at time t seconds, in centimeters by the way, is given by x is cos 80t, y equals 4 sine 40t minus pi over 4. Part A is find the initial position. Initial position meaning when t is 0. Alright? Okay. When t is 0, to find the initial position, x equals cos of 0, which is uno, and y is sine, it's 4 sine of minus pi over 4. Which is minus root 2 over 2 times 4 minus 2 root 2. Should I check this? Maybe. So maybe somewhere like here. Like, I don't know. Maybe it's actually here. You don't need to know that, but maybe somewhere there. Now it's doing this kind of figure of 8. Alright? The next part of the question is saying, determine the coordinates of where the spinner crosses the y-axis. So, actually we know it's 0. Well, it looks like it anyway, but it looks like 3 positions. So to find that, we're going to have to set, what, x to be 0? Now when x is 0, we're just going to get cos 80t as 0. Now what's missing in this question, which we usually have, is the range, right? I mean, they only say t is bigger than or equal to 0. We want 80t. Now, timesing this by 80 doesn't make a difference. You're saying 80t has to be bigger than or equal to 0. But think about it. T is 0. Maybe it's going this way. So 1, 2, 3. And then maybe it's going to come back to itself. We're basically looking for the first 3 solutions. Okay? So let's go for it. We're going to do inverse cos of 0. Which is pi over 2. That's our primary value. How do you work out the secondary value for cos? You do 2 pi minus, which is 3 pi over 2. That's 1 and 2. To work out the next one, remember guys, once you do your PV, SV, you add and minus 2 pi. But we're going forward in time, so we're going to add 2 pi. So we're going to take pi over 2, add 2 pi, which is what, 5 pi over 2. Now you can do this one as well if you want. It's going to just take you back to one of the original ones that we've already done. Okay. So what do? We're not done yet because we have to divide through by 80, right? So you're going to get t divided by 80. You're going to get pi over 160. Then you're going to get 3 pi over 160. And 5 pi over 160. Which translates to what coordinates? It does say determine the 4 coordinates. Now, on initial observation, it looks like there is some symmetry there. So, like, wherever that is, this is the negative version. But don't assume in it. Right, so what we got? We're going to sub into here to work out the y values, because we know all the x values are 0. Okay? And by the way, you're not allowed to assume this plus or minus 4 being the maximum minimum, okay? Because it may not intersect right at the base, okay? That might not be the very, very lowest part. It might have been slightly to the side, okay? So I don't want to see people in the comments section saying nonsense like that. So what I'm going to do with this, I'm going to say pi over 160. I'm going to store it. I'm going to type in 4 sine 40a, so I stored it as a, minus pi over 4. I get 0. Okay, there's one of my solutions. Then I'm going to press the calc button and change it to 3 pi over 160. I get 4. And then I'm assuming the next one's going to be minus 4. So I have 5 pi over 160. Oh, 0 again. Aha. Why is that? You're getting oh, so it's going 0, 4, then back to 0, then down here. All right, so actually, I needed to find another solution, so I'm going to add 2 pi to this, which is what, 7 pi over 2? Yeah? So I have pi, 3 pi, 5 pi, 7 pi. So I'm going to have 7 pi over 160. All right, so I'm actually not interested in this one. So these two are the same, I'm going to say. I want that one. So let's change calc to 7 pi over 160 minus 4. Nice, mate. All right, part C. This is the most important part of the question. Find the time taken to complete one full figure of 8 cycle. So it starts here, and it's going to go around. How long does it take to get back to here? So how long? What does this remind you of? I made a video, well, not too long ago about the Ferris wheel. How long did it take to complete one full revolution? That was known as the period, okay? So I fully explained over there what the period meant. I'll give you guys another quick demo. So the period is the time taken to complete one full revolution. And for the sine graph, that's 2 pi. For the cos graph, it is 2 pi. Yeah, one full cycle is 2 pi. For the tan graph, it's actually pi. Yeah, because then it repeats itself. So for sine, cos, it's 2 pi. And for tan, it's pi. But then what we discussed in the previous video is how is the period affected depending on the transformations. So for example, if you have sine of 2t plus 1. Now, we know the plus 1 is going to shift left and right, but it doesn't affect the time taken here. If you take this and shift left and right, it does not affect the period. That 2 does though. That 2 is going to divide all your values by 2. So that's going to divide this by 2. Okay, so it's actually pi. So the period is 2 pi divided by the coefficient of t. Now what do you notice here? With both of these, they have different coefficients of t. So x and y complete one full revolution at different times, okay? And that's why it's making a figure of 8. Because you can see it's basically based on distances. Can you see this distance is very small? So the particle is doing this, and it's also doing this. And then the coordinates are changing based on that. So because this is very small, it's completing the x revolutions very quickly and the sine ones very slowly, okay? So this loop occurs because in the time that the particle has done this, it has only gone from down to up. And then the particle does this again, and then the particle is going up and then back down. So what we need to do is we need to calculate the period for the x and y separately, and then we can see when they match up. That's when they meet at the origin again, which is why it's doing this. It went to 0, 0 first, right? So for x, let's talk about the period for x. Remember, it's 2 pi divided by the coefficient of t, which is 80, which is pi over 40. So the x is completing complete revolutions every pi over 40. So it'll be pi over 40, 2 pi over 40, 3 pi over 40, 4 pi over 40, etc. Okay. What about the period for y? Well, it's going to be 2 pi divided by that coefficient, which is 40. And there you go. Look, that's the same. We just said that, right? The x is going to complete 2 revolutions. It's going to do this twice by the time y has just done 1, which is why it forms this loop shape. So it's done this, y has only done 1 loop, it does this, and it does the second unique loop. So the period, or the time, for one complete revolution is 2 pi over 40, which is pi over 20. And what is this? This is seconds, so it's very quick. And that is your answer. A very, very, very important question, guys. Make sure you save this video as part of some kind of playlist so that you come back to this. You don't want to forget about it. Guys, if you learned something today, I'd appreciate if you hit the like button, subscribe for more maths content. If you're interested in my A-level maths courses, links are in the description. And feel free to join the Learn Gang Reddit to submit your own questions. I'll see you in the next video. Nice.